want to have a fresh virtual machine installed, just like I have here. I just installed Ubuntu 20.04 and I haven't done anything onto it besides opening up the terminal and Firefox. And you will also want to have an Amazon Web Services account, just like I do right here. You will want to create ideally a new account that's under a year old. That way you can benefit from not having to pay for what we are going to be doing here. But if your account is older than a year or you do not have any sort of credit grant, you will end up having to pay slightly a small amount of money for everything that we're going to be doing here. And you will want to be checking through what the quotas for everything that we're going to be using is going to be. Otherwise, if you start using this video tutorial and deploy something and then keep it running and your account is not eligible to do this for free, you will end up having to pay for something, and you might have a little bit of a surprise at the end. So good idea is to, if your account is new, don't worry, I don't think you'll have to pay for anything, but just in case, and if your account is not under a year old, keep on checking the billing dashboard and see what everything is costing you, because Amazon Web Services is not free. And even though there's a lot of ways of using it without having to spend much, you might end up racking up some costs like I have right here. So yeah, once you got the virtual machine installed and the Amazon Web Services account created, then we are ready to start installing stuff. All right, so once we have the virtual machine and we have the account, we are ready now to start installing things that we are going to need to do this. So first thing, we are going to be using the Amazon Web Services client. You don't need these. You can make it through without using the client, but it's going to make things easier. So we're just gonna go ahead and get the link. You can find the links from the file that's going to be explaining everything in detail. It's going to be down there in the description. And you can just go ahead and scroll down onto this link, go to where it says Linux, grab the Linux commands right here, and just copy that and go ahead and paste them. Now here I'm missing curl because I haven't installed that, so you are going to want to install everything that you need before you go ahead and execute these commands. So as I said, this is a fresh install of Ubuntu, so just for that reason we are going to need to install things like curl and type our password and such. And such and such and such. There's going to be a bunch of things that we're going to be missing, so just bear with me as we pull through it. All right, so we got that installed. Now we should be able to do a curl and we get the files. And now we can go ahead and finish clicking that. And now we should have the Amazon Web Services client installed. We can do AWS version like this. And there we go, we got the confirmation that it is installed. So the next thing we are going to be installing is Homebrew. Homebrew is a package manager and we will be using it to install EKSCTL. So what EKSCTL is, it is a tool that's basically means EKS control tool that we use to interface with the EKS service from AWS. And it abstracts a lot of the things that you have to internally handle in order to set up a Kubernetes cluster. It's basically going to simplify a lot the installation and creation of a cluster for us. So for that reason, we want to be installing Homebrew because we will not only install with it EKSCTL, but everything else that is going to be required to work together with it. So to install Homebrew, we go to the page brew.sh and we grab this link down here. And we are likely to be needed to install some additional things. So for example, we need Git here. So let's go ahead and install Git. And then we'll execute the same command once more. And we will have our Homebrew installed. Just give it a minute. All right, there we go. Now we paste that same command, we press enter once more, and we'll let it do its thing. It's going to take a little while, so I'm gonna cut it here up until it's done. Okay, so Homebrew has finished installing, and before we can do anything with it, we will need to execute a couple more commands. So there is another web page where we can find a series of commands that we will need to run in order to make sure that the system recognizes that Homebrew has been installed. So we can also find these links down in the description in the big file explaining everything. And we can just go ahead and copy this and execute them. You can copy them all at once as well. And just go ahead and do that. Let them run, and once that's all done, we can just try and do this. Brew install hello. That's going to install basically a hello world test program to see if everything's running as it should. And once that is done, it's just going to be saying, it's going to be showing a little icon with a beer bottle. And if that's all running and good, then we know that we have our Homebrew installed properly. So once the hello program has finished installing, we can go ahead and finish installing all the requirements. So we will copy this command here, and we'll just run that onto our system. That is, of course, we have the Ubuntu or Debian distribution. I assume that's what you are using just for the sake of this tutorial. So we'll just copy this, paste it, and let it run. Once that is done, it's installed all the requirements, so we can go ahead and start installing EKSCTL. So for installing EKSCTL, we will be executing the following commands here. First of all, we'll do brew tab weaveworks/tab. This command will add the EKSCTL repository, and the following command, the brew install weaveworks/tab/EKSCTL, will actually install EKSCTL onto our system. Here I already installed it, so I didn't do anything, but you of course will see the program being installed just like when you did brew install hello. And after that is done, you will be able to go ahead and do EKSCTL version, and you should see the version of EKSCTL that we've just installed. So if you've gotten to this point, if you have the version being outputted here, then we are on the good road. So now that we have EKSCTL installed into our system, we need to configure AWS, the client we installed into our virtual machine, so we can connect it with our actual account on AWS. So the way we do that is we type AWS configure, actually type it right, and we will be prompted to introduce the AWS access key. So the way we obtain the access key is we go to our account and we press up here where it says the name of our account, and we go down to security credentials. Once we are into security credentials, there is this tab called access keys. You want to type, open that up and create a new access key. It will show you the access keys right here. Don't worry, I've already deleted this one after the video has been done, so there's no reason for me to be hiding this. But what you want to be doing is you want to be copying the access key and pasting it onto the command here. And then it's going to be asking you for the secret, so you want to be copying this and pasting it. You want to download the key file just in case you might need to reintroduce the access keys elsewhere. Otherwise, you will not be able to find the secret access key afterwards. So make sure you download this and keep it saved. Now, once we've typed both the access keys, it's going to be asking us for the region name where we want to be operating. So we are just going to be leaving it as it is because we are going to be working with a default region name. Region names are a way with which we identify what databases we are going to be operating as a default, but we don't need to change that for the sake of this tutorial, so we just leave it as it is, same as the next one, and that should conclude the configuration of AWS for us. Okay, so now that we have everything set up, we are ready to start our deployment of Kubernetes cluster. So for that, we're going to be doing the following. We'll type EKSCTL create cluster, then we'll give it a name. We'll call it cluster test, for example, and then we can indicate the type of node that we want to be creating. So in this case, we will create the node type t2.micro. This is one of the free tier nodes, so you don't have to worry about any expenses by using this type of node. And then finally, we'll just let it know how many nodes do we want to create. So in this case, for the sake of further testing, we are going to be creating 5 nodes of this type. So once you've got all of this, we can just go ahead and launch it. And it's going to take a while. It will take quite some time, but after this is done, you should have your cluster up and running on EKS. And then you should be able to go ahead and check in here in clusters where the cluster is. It will show up with the name that you gave it. So let's just wait until it's done and we'll resume the video once that is the case. So after 20 minutes, give or take, yeah, basically about 20 minutes, our cluster is being created. And yeah, don't worry if you see the waiting for CloudFormation stack message appearing for a long time. It doesn't mean that it's stuck or that it's not working. It just means that it's doing what it's supposed to be doing, and it takes quite some time. And if everything's good, you will have this message: EKS cluster, whatever the name you've put, is ready to go. And it's been created in the US West 2 region. That is the default region of AWS. So now in the AWS command panel, whatever that's called, we gotta search here for EKS if you are not here in this panel yet, and you have Elastic Kubernetes service. We click on that and we load up our cluster. Should be appearing here in clusters on the EKS cluster tab here. So if you see this with your cluster, it's been created and it's there. Everything is good so far. We can also go ahead and see all the different nodes we created here. T2 micro, as we said. So now we're going to be trying to deploy something and testing out some stuff with this cluster. So the first thing we're going to be doing onto our cluster is deploying a very simple Nginx server. The link will be, of course, in the description. We will just be deploying it with 2 replicas, going to be using the default link. Even though we have 5 different nodes, by the way, we can already use kubectl because it's been installed together with all the dependencies when we installed EKSCTL using Homebrew. That is the attractiveness of using Homebrew. And we can already do kubectl get nodes, and we'll see our 5 nodes are ready to go. So for the sake of deploying this, we're just going to be copying this link right here, or this command rather. And this will proceed to deploy onto our cluster the Nginx service. Now we can already check if those pods are being created with the described deployment. Rather with this command instead though. But we can see there is 2 replicas being created, 0 available, 2 unavailable still, and now we can see they are already both up and running. Okay, so now we have those replicas created, and we will be creating a service with those. For that sake, we will be using a version of this command that I kind of forgot sometimes, but what we're going to be doing is exposing our deployment, and we will be changing the name of the deployment to the name of the deployment that we did, not the one that I copied. So we will be doing Nginx / or however that's called deployment, and we want to specify a type load balancer. That way we can access the service that we've created or that we've deployed onto the cluster from anywhere on the internet, and we can just give it a name, or we can keep it as it is. And you can see here we got our service has been exposed. So we do kubectl get service. And if we do this a little bit bigger, actually we cannot do it because my resolution is not big enough on the screen, but we have the external IP now assigned. We have a load balancer exposing this IP. So we can take this massive string, we can go onto any browser, and we can type this there. By default, of course, they are going to be doing it on port 80, so we don't have to type the port here. But after a few minutes, this will actually give us our it will return the default page of Nginx as it updates and everything's falling into place. Give it a minute. In the meantime, we can do a curl, and the same thing, paste the IP and then the port. and it's still not resolved, so we gotta wait still for a little bit. There we go. Okay, so here we go. Now it's been loaded. It does take a little bit. You just gotta go through, just like the same thing that it took time while creating the cluster. It's the same reason why deploying anything into it takes time. It has to go through the cloud formation, and that just slows down everything. But as you can see, we can access the welcome page of Nginx, and we can also make a curl, of course, and we can see that the service has been created and it's up and running. Right, so if the previous deployment that we did was all successful, we are going to go ahead and clean that up, delete the service and the deployment that we created, and we are ready to go and move on to testing out horizontal pod autoscaling. So horizontal pod autoscaling will basically increase the amount of pods that we have created into our cluster based on the usage of resources. Now, in order to be able to use horizontal pod autoscaling, we need to install the Kubernetes system, metric system, into our cluster. So effectively, we will be creating a pod that will be measuring the resources that the different pods are using. So for that, we will have, of course, this link installing the Kubernetes metric system. And I already did this, so you go ahead and copy this and paste it in there, and it's going to deploy one single pod instance for the metric system. And once that's been done, you can go ahead and copy the second code, second command, and it will show you if it's already up and running. As you can see here, it's available, it's running onto my system. Now, with that in place, we can move on to trying out and seeing how this works. So for the sake of that, we have the official tutorial of horizontal pod autoscaler, and we will be coming down here and testing it out with the deployment that's being given to us by the tutorial. And for the sake of that, you will just be copying the first link, and that will be proceeding to deploying an Apache PHP service that we will be using to stress out and see how the autoscaling is applied. So we will be creating the deployment with the first link, and with the second link we will be creating the autoscaling based on the name of the deployment, and then we'll set it up to 50% CPU usage with a minimum of 1 pod created and a maximum of 10 pods. It's there at the end, you can really see it. Now after that's been done, you could go ahead and copy this command, and when you paste that, it's going to show the usage of the CPU from the deployment that we created named the PHP Apache. It's got, as you can see, a 0% usage right now with a minimum of 1 pod and a maximum of 10 pods, and right now we have only 1 replica running. So what we're going to be doing is we will be keeping this up like this, and we are going to be executing it with watch before it, so this way it's going to be updating automatically. And we'll be creating a second tab of the terminal, and we'll be copying the following command down here. Now what this is going to be doing is it's going to be stressing out the service, and it will make the usage of CPU go up, and it's going to go way past the 50% target, meaning the autoscaling is going to be creating some more replicas, trying to balance this down to 50% or below. So we create a second tab down here, and we can go ahead and paste that and let it run. It's going to start executing itself. And then, by the way, if you are not able to run EKSCTL or any of the things that we've installed in like a second terminal, you might want to go ahead and go back to the Homebrew documentation, Homebrew on Linux. Remember, we used these commands down here after we install Homebrew, and you can go ahead and copy all of this and repaste it here, and it will allow you once again to be able to run all the commands that we installed with Homebrew. It's a little problem that I run into, and that way it gets fixed. Now, once that's running, you can see that the stress levels are going up. We have 128% CPU usage right now. So as you can see, it's starting to create some more replicas. We already have 3 replicas, and it's going to be going up and up and up to the point where if our cluster is capable enough, eventually the the CPU usage will balance itself out when we have 10 replicas. Now, given that we use the free tier instances for our nodes, they might not be able to remain below 50% CPU usage, but that's going to be depending on such a thing. The important thing is that we see that the replicas are automatically increasing, and once we stop the service here running, we can do Control-C. It will stop stressing out the service, and after a couple minutes, it's going to take like a minute at least. Once this goes below 50%, it will start deleting the replicas, and it will go down to another, again, to one single replica. So after a couple minutes, when we see that the number of replicas in the output from that command goes down to 1, we can be sure that the horizontal pod autoscaling is working. So now we can just delete that deployment using the last one of the commands from the horizontal pod autoscaling link. And once we got rid of that, now we can move on to the next thing, which is going to be testing out the vertical pod autoscaling. So now we don't have to get rid of the metric system that we installed. That should still be running because it's going to still be used for the next test. So for that, we will go on to the next link, vertical pod autoscaler tutorial. And we will be cloning the following files onto whatever folder you want. I've already done that and they are downloaded right here. So you go ahead and execute the first command and then execute the next one, which is just going to move us onto the folder that we are supposed to be. And then we will ignore this one. This is just in case you want to, when you want to delete the vertical pod autoscaling. But for the sake of setting it up, we have the sixth one right here where it says vpa up.sh. We copy that, we paste it there, and it's going to be installing creating all the pods that are necessary in the system for this to be running. And once that is the case, we can go ahead and copy this command and we will see if everything is running as supposed to. Just give it a little minute. It's got to create a lot of different pods into our cluster. There we go. So we can go ahead and check that out with this. And we have this one still creating. We'll just give it a couple more minutes. By the way, it's a good idea now that we're waiting to just have your SSH key created. So for the sake of that, go ahead and type SSH/khen and then just keep it all as it is. Press enter a couple times until you see this little drawing. And once that's done, your SSH key has been created and it's ready to be used. We'll probably need that in the future. So we go ahead and execute that same command once again. As we can see now, everything is up and running. So we are ready to start testing out the vertical pod autoscaling. So down here in the same web page, we have some deployment that we're going to be applying to our cluster. So we grab the first link of that and we are going to be pasting it here. And it's going to be deploying some stuff onto our cluster. There we go. It's been created. And we will see how many pods do we have. We're supposed to have 2 pods. There we go. Both pods are created. So for the sake of this, we are going to be checking out with the description what resources these pods have assigned to them. So for that, we will be typing on the following command where we are describing the pod based on its name, and the name includes, of course, this long ID. So make sure you type that in instead of the one that's already been given to you. You gotta change that for your own ID. You press enter with that. If it's typed correctly, it will show it to you. Otherwise, you just gotta make sure you don't mess up like I did right there. And here we go. We have a long string of text, and what we are going to be looking at is the following. We have the requests, and we have the CPU that is being requested to be assigned to this pod, and the memory that's being requested as well. So what's going to happen is that the system is going to be requesting for these pods to be relaunched with higher amounts of CPU and memory, because the service that's running on these pods is actually needing more than these resources, needs way more than this. So we will watch as the new pods are created with the following command, and after a couple minutes they will go down and they will be restarted and a new pod will be created. Now this new pod will have a different amount of resources requested based on the actual needs of the pod. So for now, we just wait. After like a minute or so, this the new pod will show up, and we'll be able to inspect it and see what the requests for resources are. So we can see here it's taken down one of them, and now it's opened up another one. So we can go ahead and check the description of that pod. The first part of the long string should be the same. We just need to change the last couple digits. And there we go. We can see that now it is changed. It has changed the requested amount of CPU and memory to the same amount that we, not exactly the same amount, but a similar amount that we have in the tutorial. So basically our pods have been auto-scaled vertically. Now we did not create horizontal pod autoscaling for this deployment, but both things could work in parallel. So you could have a cluster where if your nodes are stressing too much, it will create more replicas, and you could have replicas that require more or less amount of resources based on what they are really using at that time. Altogether would create a much more scalable cluster altogether for your services to basically never go down. Now, once we've done that, we can go ahead and delete this deployment, and we can move on to the next thing. So the next thing we're going to be doing now is testing out the cluster autoscaling. Now what that means is it's going to be creating new replicas of the nodes themselves instead of the pods of the deployment. So for that, we are going to be having to create a new cluster altogether. So first we want to be eliminating this whole cluster, and for that we will be doing the following. We'll be doing EKSCTL delete cluster, and whatever cluster name you gave it, we are going to have to type that. So make sure what the name of your cluster was, cluster test, and we'll let that run. It's going to be taking a while as well, but it will end up deleting the entire cluster. All right, so after a couple minutes, our cluster is now gone. We can see here clusters 0, everything's been deleted, so we are good to go. And we will proceed to install, in this case, to set up the cluster autoscaling. So we have chosen to use Carpenter. Carpenter will basically create nodes and eliminate nodes on the cluster based on the necessities of them. And for the sake of that, we are going to be installing Helm. So to install Helm, of course, there's an official webpage. So we go over there. And right here we have a script which we can just go ahead and copy. And in this case, we have those dollar icons. So we'd rather do it manually. By the way, just go back to a folder that's safe to use and just curl the data from there. And then execute the next command. And finally, the last one. In this case, we should now have Helm installed after we run all these commands. And there we go, Helm has been installed. So now we have Helm into our system, and we can go ahead and check out the Carpenter website. Getting started with Carpenter. So for the sake of installing Carpenter, we need the Amazon Web Services client, which we already have. We have EKS and the kubectl. That's all been installed with Homebrew. And now we have Helm installed. So first, we are going to be following this tutorial very closely. And the reason for that is because the way it works, it has these environment variables that are going to be making things very easy for us. But if we change anything, it might be a little bit hard to get it back on track. So first, we make sure that everything looks like we want. So our cluster name is going to be the user of our virtual machine, and that's going to be Carpenter demo, and it's going to be created in default region, which is already the same one that we used before. It's US West 2. And the Amazon account ID is going to be pulled from where we already created it. So we are good to go. We just type that in, press enter, and wait for a second, and there it is. Those variables have been created. And now we can go ahead and create our cluster. So for that, we're going to be using this YAML file. And I want to change some things. So I created here a little little text file so we can go ahead and change some stuff. So we just want to change the type of cluster. Instead of having, or rather instance, instead of having a very big instance, we're going to be having a T2 micro. This is the same one that we used before. It's just going to be a cheaper way, a cheaper instance that we're going to be launching. This one is straight up just free. So if we use the other one, we will maybe be having some other, actually I don't want to save this. We probably will have to pay if you don't have an account that is completely free to use, but we just go ahead and copy that and then paste it onto here. And it will be launching the cluster to be created. Just like before, it will take a long time. Once this is done, we'll go back and keep it going from here. All right, so after basically 20 minutes, our new cluster has been created. We can go ahead into the Amazon Web Services EKS tab. And just like before, our new cluster is created. You can see my username and then the name that was by default added onto it. So here we have a cluster ready, and now we are going to be starting to set up everything we need to create a cluster that's basically going to have autoscaling. So for that, first of all, we need to create a role. Now the way Carpenter works is through a role, which basically a role within an Amazon Web Services account is a user within our account, and we will be creating this role using the following command. So it's already been done for us, and we will be granting some permits. So like we will allow this role to be doing stuff. So basically this role will be able to create the nodes for us, and it will be able to do what we need it to do. So first we just execute the following command, we let it run, and once that one's done, shouldn't take that long, we will go ahead and use the second one. And with these, we will have created a role that Carpenter will be using to launch new instances connected to our cluster. Okay, so this has been created, that's finished executing. So now we're going to be copying the second command and we'll paste that into it. And that one doesn't take that long. So there we go, we have that ready. Now we are going to be creating the actual role. Here we just set up the role for Carpenter node. So for every node that's created with Carpenter, there will have this role. And now for the controller, we are going to be creating another one. In this case, just copying the following command. Hopefully it doesn't copy the part down there. Okay, there we go. Copy that, we paste it in there, and it's going to be creating the role. Just like the command we just did before that. It shouldn't take that long, but it just might. Now after that, we will be executing the following command. Only for the first time you're using EC2 spawn this account. So since we are assuming it's the first time we are using anything related to creating clusters onto AWS, we're going to assume that it is our first time. So we will also be executing the following command once this one's done. Again, I don't know how long it's going to take right now, so I'll just restart the video once that finishes. So it finished just as I pressed the stop recording button. So anyways, we take the next command up here and we just copy that. It doesn't matter if you copy the commands, they're not going to be doing anything. Just type that in there. It should take no time. Has been taken. Service role, blah, 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 has been done. Oh, it's already taken. All right, that's because my account, I already did this. Okay, so in your case, it shouldn't take. That's already taken. But since I've already done all of this, it's not necessary for me. Now we are going to be installing Carpenter using Helm. So that's why we needed Helm. We go ahead and we can copy all this. And we can paste here, and it's going to be installing Carpenter. I gotta press enter on the last one. release does not exist, so it's going to be installing it now. Just for the sake of it, I'm gonna cut the video here again. Okay, so once the installation of Carpenter has finished, we just executed install Carpenter Helm chart. Now we can go down here and go past everything that says optional, and we go on to the provisioner. So we have another big command, and we just want to copy all of that. Copy, paste, and this will create the provisioner. Now the provisioner is going to be the component that's going to be in charge of creating and destroying the different nodes based on the needs of the cluster. So first, now we will be testing out if everything's working as intended. So for that, we will be using a deployment here, which will use an image, and it will start with 0 replicas. So we will have no instances of the bot being created, but then the target's going to be set to 5 replicas. So right now, if we do kubectl get nodes, we only have a single node created by the deployment, rather the cluster creation that we did. And once we execute all these commands, it's going to start generating some more nodes. I think it will only create one more node. So we're gonna go ahead and do that. We'll copy this whole command and we'll run it. And it's going to create a deployment. It's going to say that it's supposed to be scaled from 0 replicas to 5 replicas. And now we set up Carpenter so it can control, well, Carpenter's already set up. So here we're just seeing the output from the logs of Carpenter. So Carpenter is noticing that we need some more replicas, so we can go ahead into our other tab of the terminal and we can do watch kubectl get nodes. And as we can see, another node was just created 28 seconds ago. And yeah, this is just the log of the information of why that has been the case. And we can see that yeah, we just have another node now. So Carpenter automatically started another node so we can host the replicas. And I don't think it's going to create another one, but for the sake of seeing how it destroys it, we could just cancel this command so we stop seeing the logs, and we could do the node termination. In this case, we would be automatically, well, the node that just got created would be automatically getting deleted once we actually delete the deployment that we created. So we can see we still have 2 nodes, no more nodes are being created again. This whole block of text, that was just the logs from the Carpenter pod. So now when we do the delete the deployment, after a couple seconds, the last, or rather the node that was created by Carpenter will be disappearing.